Hi folks, welcome to the Breaking. My name's Henry, and today, the day of release, I'm actually at VCF East, and I've got a video working for that one that'll release here in a couple of weeks. But today, the day of recording, we're going back to the USB adapter for the CoCo. That's right, we're going to take another gander at the USB keyboard to CoCo keyboard adapter, where this time we're going into mapped mode. That is to say, instead of having like the raw keystrokes being sent to the CoCo, we'll work on mapping those keystrokes so that I don't have to remember which key is the semicolon and which key is the colon because they're in different places on the CoCo keyboard. Instead, I can use the layout that's actually on the keyboard in front of me, the regular old bog standard USB keyboard. So we're just that much closer to having this thing buttoned up and fully complete. There's one more feature set that I want to add after this one, but right now let's focus on getting mapped mode working. So sit back, relax, and enjoy the hair pulling as we get the USB to CoCo keyboard adapter working with a mapped mode. So first, let's do some quality of life refactoring. Since we're going to have raw mode and matrix mode be kind of separate things, let's move some of this stuff out into its own header file rather than having it in the middle. I'll take the raw matrix information, break that out. Okay, so let's grab tusby.h. And while I'm at it, something that's generally good practice is multiple inclusion protection. Now, aside from getting that out of there, I want to get my defines that deal with the timing for the MT88 into their own header file. We'll do inclusion protection again. So now I want to get my globals, and I want to get my function prototypes into its own header file. So we see here in the LED blinking task that we've got a static value that we initialize. In the context of a block, like in block context, static means persist beyond the closure of the block context. This will remain here, whoops, and it'll be accessible every time we come in. So it's not reset every time it comes into the function. It's not reset every time it comes into the block. On the scope of the file, however, the file level scope, what this static keyword does is it says, this name is only valid for the current compilation unit. That is to say that if I include this file in KB USB to CoCo firmware.c, then that's going to be static. That's going to be the function CLS in here. If I include it also, this file also in another C file, that's actually going to be a different definition that'll need to be used. It'll be a different variable that'll need to be used. Screen is dirty is going to be different. These variables are local to the compilation unit, the C file they ultimately wind up included in. So that's gonna help with potential name collisions if we have that problem. We'll need a way to tell the system that we're talking to the Pico, not talking to the CoCo. So I'm using the GUI key as that escape key. So we'll look at that. All right, GUI is pressed. There's a couple more we need to know. We need to know if mapped mode is active, and we need to know if we are recording a macro. We're not doing macros this time around, but we will be setting up for doing macros when we get back to it. In the meantime, I do want to be able to know whether we are in the mapped mode or whether we are recording a macro. So as I'm sure you've noticed, we've got a whole bunch of white that used to be blue and a whole bunch of underscores here. We need to get the inclusions taken care of. And that should, yes, that made all sorts of that red go away. Oh, I need to change these names here. So that's all just some simple refactoring. Let's get this tested, make sure nothing broke. Oh, it's not happy with something. I'll bet you. Oh, you know what? These little red jobby doos help me find things that are wrong. Compile and see if it's happier. It's much happier. Nice. All right. Aha. I also have put together a board that has the flexible cable that goes into our CoCo 2 that I'm working with right now instead of CoCo 1. And this is a double wipe socket. The only thing that changed is we've got this cable, we've got this socket. You know, I flat soldered that, but it's the same board that we were using on the one. It looks like we've got, yep, the LED is blinking, so we're fine. Composite, okay, good. Do we have keystrokes? Is everything still working? Oh yeah, things look good. At any rate, this looks like it works real well. It looks fine. So let's get back over here and keep going, putting things together. So I need to have available for any given report that comes in, the new presses and the new releases for that report. So I like thinking of these things in the context of a matrix because it's like how I've been thinking of the CoCo keyboard. So if I take, it's a 1 byte per keystroke report, with the exception of the modifiers, and we'll deal with that here in a minute. Modifiers don't show up in the report other than the modifier byte. But we have up to 6 keystrokes, and that includes the modifiers. To matrix that, to turn that into a matrix so I've got everything simultaneously, I can take the lower nibble of a key report, and that can become a bit in an 8-bit, in an 8-bit word. And then I can have 16 of those, which then becomes my row. So I've got a row of, is that correct? I don't think that's correct. No, I need 16 and 16. There we go. Yeah, I need 16 rows and 16 columns in order to make the full 256 array. So I need a 16-bit word, and I need an array of 16 16-bit words. The low nibble of the key code becomes the position, the bit position for the column, and the high nibble becomes the row. All right, that sounds doable. There are other ways this could be done, but this is the way that works for my brain, so let's do that. Let's work on that then. Now the modifier keys. Blessedly, if I look over here at, there we go. Let's get that and let's go to the definition. If I look down at the actual modifier keys themselves, here we go. Control left is at 0, shift left is at 1, alt left is at 2, GUI left is at 3. These numbers here correspond to the bit positions we find them in the modifier report. For instance, if the left control key is pressed and only the left control key is pressed, the modifier byte will contain bit 1. It will be 1, or bit 0. It will be 1. By the same token, if the right control key is the only one pressed, it will be hex 10. That is to say, bit 4 will be hit. So that makes that easy. These will be easy. These are easy to map in then. Now we need to put every key that came in into the matrix. And again, what this does is it takes the upper nibble of the key code that we've received. That becomes the index in the report array, or in the matrix array, by left shifting that by right shifting that 4 bits. And then we take just the value 1, we left shift it according to the lower nibble, and that gives us the bit position. I just want to check at this point. That should take care of that. Let's compile it and see if it breaks. Compiled on the first go. Maybe this will actually work on the first go. Wouldn't that be interesting for a change? I mean, it's slower than molasses, but hey, it's giving me what I need to know. Control. Okay, things look good. Okay, that looks pretty good. Slower than molasses, so we can't use it anywhere else, but it looks pretty good. And since it's slower than molasses, we just won't leave that in here for right now. We know everything works, we're fine. However, now I've got the problem of all this code that was actually doing the work, just kind of sitting here, not really doing much of anything. So all this can be broken out into its own function. All right, I want my toggle between mapped mode and raw mode to be GUI Z. I'm using GUI as the escape key sequence to talk to the Pico. In XROAR, Control Z is how you switch between mapped and raw mode. So I'll just borrow that muscle memory. So now I need to figure out how to check if a key exists in the matrix. This should be, it's basically the reverse operation of, it's reverse operation of creating the matrix. Now, since we're only using these previous and current values here within the context of this function, we can grab those and move. Those no longer have to be global. Those are fine. I'm not worried about clearing the screen at this point. Rotate the key press data. Now this is the data that was encoded to go to the CoCo. Let's see. I think that can go away. Because we're not even going to get here. We're not using that. That's matrixing that. That's matrixing that. Then handling all the other keys. Great. And then we're calculating the key state changes. Now, this particular case, I want to get rid of all this like clear block and put block stuff. So here's the trick. I do believe I want to take this duplicated functionality here and map it out into its own task. And that should work. Now, if I've done this correctly, when we test this on the code, we should see something come up on, as far as telling us that we're on the debug screen. We should also see keystrokes show up in raw mode on the CoCo, but not in matrix mode. So let's give this a compile and see if anything broke. Uh-oh, something broke. What are you still? Oh, I forgot to change out those function calls. That's what happened. That's much happier. All right. That's going to drive me crazy. Oh, I need to find that and get rid of it. All right, try that again. Left, there, it's that. Let's see how that, yep, we're looking good on that, looking good on that, looking good on that. Good. Now, if I switch over, GUI key pressed, GUI key. Uh-oh. It's still seeing it in raw mode. It's not switching to mapped mode. That's not good. I see what I did wrong. That needs to happen there. There we go. Now the index is actually what I want it to be. That should fix it. That should fix it. Let's find out. So, fun fact, that was turned on because that was power from this USB cable here, powering the Pico, back feeding into the CoCo. That's a hardware issue that I'm going to have to fix at some point. Still not seeing it. Did something wrong. Wonder if that fixes it. And it's still saying it's in raw mode. What is really going on? Okay, I gotta work this out. That is my low order nibble. I know that to be my low order nibble. That'll be the bitwise and that's my mask, which is what I want, and that's going to be hid key Z and OX F0. That will need to be left shifted 4. This will need to be right shift 4, and this will need to be left shifted. No, this needs to be 1. There we are. That's the mask. Let's try this. Will this work? It still thinks it's in raw mode. What am I doing wrong here? I just want to see what this is going to pull in. Okay, it sees the 1D, and now it finds it in map mode. What the heck just happened here? Okay, it's working. What does the computer show? Let's reboot the machine real quick. Get over here. So I should see key sequences. Yep, I do. And if I go into mapped mode, it sees nothing. All right, it's working. I don't know what the heck happened, but it's working. Maybe I forgot to build or something. Y'all can go back through and like say, ha! If I did forget to build, please feel free in the comments. Let me know that I forgot to build, if that's what happened. So it sees the raw sequences, it sees the mapping sequences, it sees what it needs to see. How am I going to do a mapping? Every one of these key presses may very well be combined with up to 3 different modifiers on this keyboard itself. Now, here I'm not going to differentiate between the left side and the right side of the keyboard, or the right side and the left side of the keyboard, as far as which Alt-Shift-Control is going to be, but there might be, there's 3 bits that I need to pay attention to. So that's going to give me 8 possible sequences for every useful key on this keyboard that might be sent to the CoCo. The CoCo itself, in a given key sequence, so like I send, for instance, I guess like a bracket, an open bracket. That open bracket is, if I recall correctly, a shift up arrow. So I need to be able to send not just the up arrow, but the shift at the same time. And the only way to get that to work properly that I can think of that's going to be expedient at all is to have every single keystroke, that is every single new key press, along with the modifier set that's currently depressed, to map to a single chord for the CoCo key matrix. That's a little bit of a pain. That's going to take a while to write. But at the very least, let's look at how bad this is going to be memory-wise. Each keystroke on the CoCo will fit within 8 bits. So that'll be that. We know it's, let me do this. We know that there will be 0, 1, 2, 3, 4, 5, 6, 7. So that's going to take 3 bits to cover that. Again, that's going to take 3 bits to cover that. That's 0, 1, 2, 3, 4, 5, 6. It's going to take 3 bits. So I need 6 bits to fully map this keyboard. If I use a UNAT, that's going to give me enough of them. Now, I have 256 potential key codes from the USB keyboard. The USB keyboard, because I'm only using, I don't care whether it's right or left, as far as the 3 modifier keys that I'm going to use, Shift, Alt, and Control. That's 3 bits, which is going to be 8 potential units, and we determined that we said that it was going to be a chord of up to 4 individual keys on the CoCo, and this bad boy needs a name over here. Since I don't use OS 9 or any of the other stuff, I'm just going to make this extended color basic, an extended color basic map. All right, and that's going to be a lot of entries. I don't want to do that manually. And I don't want to faff about in C. I don't like Python. I want it to spit to the console. I'll use PHP. Three bits and 3 bits. I'm going to use octal here for defining the map. It'll help my brain work a little bit better. I'll have 1 digit for the column, 1 digit for the row. And so the control key is on row 6, column 4. Yep, that's correct. And the modifier bits, and we'll do this according to the USB keyboard modifier bits. If I'm just throwing a key at the CoCo and not doing any real mapping with it, that was annoying, and it looks like it's probably going to work. So let's see about generating our map here. Just a quick tour of what we've done. We have set up the baseline map. This is the, if nothing's moved around, this is the basic CoCo keyboard. Then we map in the numeric keyboard because it doesn't do shifts, and therefore we don't define it. And then we map in now we map in the specials. You can see like maps to add, the shifted 2, shifted 6, blah. These all map in. And the trick is that I need a way to tell whether a particular byte is actually used or not, because 00 is a valid key matrix address. I can't use 0 as a null indicator. So I actually am going to use octal 100 as a null indicator. This 6th bit, 0, you got this 7th bit here. If it's hot, if it's set, then I will have a null value. I don't send anything to the keyboard. So let's see what we get. Okay, good. There we go, 001. Yep. That looks good. That looks very good. That's A, that's B, C, yep. All right. So that should work for the mapped mode. Now that I have the mapping put together, I have to actually use it. So that happens in here. In any given report, we should have a maximum of 3 key presses. Or I'm sorry, maximum of 6 key presses. Some people may not like this, but it works. Casting to or forcing to a Boolean using the double knot. Remember that in this particular version of C, a Boolean is either a 0 or a 1, and a 1 is a 1. 1 is true. Now we need to get extract our presses. And the presses are going to be in the press matrix that we made way back up in here. So of the 2 octal digits that make up the row and column, I need to shift this to the right 3 to get that upper digit. And I want to make sure that masks off correctly. And then I need the lower 3 digits. And this is a press, so that will be a 1. Nope. Yes, that will be a 1. All right. Now, here comes the next fun part. I need to have the thing just hold off for a minute, not a full minute, so that the CoCo has time to recognize that a key has been pressed. So, along with a send, I need to pause. So, I forgot something else. This will send, doing it like this will wind up with it being a function call. I don't want a function call there. I actually want it to try to do an inline. So let's inline this. Let's inline this. Let's make sure that you're inlined down here. And the pause should be simple. I need to wait for a certain number of milliseconds. And for me to do that, I need time.h. Oh, right. That's why you're complaining, because I changed the function prototype and didn't bother to change the function call. Okay. And if I want to do an MT8808 pause, now I want to give it like a frame and a half, which is 25 milliseconds. So we've sent the press. I need to pause. And the release is exactly the same as the press, except the data value changes to a 0. That should take care of it. Yeah, that should take care of it. Let's see if it compiles. Woohoo! It compiled! Okay, will it work? That's the next question. We have the keyboard. All right, so raw mode, that's all working. All right, what about, we're in mapped mode. Oh, nice. Haha, check that out. Shift 2 gave me the @ symbol. We're looking good. Yup, that's a Shift 0. And if I don't know if I showed you, but I did map the caps lock key to Shift 0, so that should give me. I hit caps lock just there. Minus and oh, yep, that's correct because the left arrow is the underscore. Equals and plus, good. Backspace is working. Shift backspace does what it's supposed to do. Tab does nothing as expected. Let's see. Yeah, there we go. All right, brace, shifted bracket. Yep, there we go. Nothing from the slash of the pipe, which is expected. Semicolon, colon works. Good. Apostrophe. Yeah. Ooh, Yep. That's working. That's doing what I expected to do. Good. Enter gives me a syntax error. That's good. It's fine. Everything else is working just fine. Let's check the numeric keypad. Nice. All right, numeric keypad shifted, shouldn't do anything, and it does not. Good. Oh, right, that's nice, wonderful, marvelous. I'm happy. I have a functioning mapped mode. Yeah. We'll call this done for now. Next time we get to this, we'll go into the macro. We'll go into the macro stuff. I have a working project. Yes, it's functional. It's working. It does what I want it to do. This is going to be so great when I'm over at the classrooms. Day of recording is not day of release, obviously. So, but by the time this hits, by the time you're watching this, if you're watching this weekend of release, I'm going to have this with me at VCF East. It's it'll be there, and I'd love to see you there. If you're there, just come and visit me over at the classroom, or if you run across me at VCF East, just tap me on the shoulder, say, hey, love to meet you. At any rate, how close to done is this? It's all it's got is macros left for me to consider it complete-ish. There may be a couple of mappings left, but those mappings are going to be more maintenance than actually complete project. I want to get the functionality of the macros in because I got the functionality of the raw mode, the functionality of the map mode. Adding more maps is maintenance. I need the functionality of putting macros in there. So that we'll have a fully functional keyboard replacement using stock USB keyboards. It'll be so great. And I want to thank each and every one of you for tuning in to the Break Key. It's a joy just to know that you guys are out there. And like I said, if you're at VCF East on the weekend of release, please come and say hi. I'd really love to say hi to you. So thanks for joining me right here at the Break Key. Be sure to like, share, and subscribe, and see you next time. If not, later today, or tomorrow, or Sunday.